So here is a special type of an exponential equation. We know that it's an exponential equation because notice the exponent. The exponent has the unknown x in it. So that's what makes it an exponential equation. Another thing to notice is the exponents on the e. E to the 4x, e to the 8x. So 4x times 2 is equal to 8x. So look at the rule, one of the rules of exponents. A to the m whole to the n is a to the m times n. So if you go e to the 4x whole to the 2 is equal to e to the 4x times 2, which is equal to e to the 8x. So e to the 8x can be written as e to the 4x to the power of 2 plus 4 e to the 4x, basically to the power of 1, minus 21 equals 0. So this is a special type of an exponential equation that can be solved using the techniques that we use for quadratic factoring or solving quadratic equations. It can be solved either by factoring or by using the quadratic formula. So notice the pattern here. It looks like y squared plus 4y minus 21 equals 0. So this pattern, a certain term the whole squared, a certain term to the 1, and then a constant, that really is the quadratic pattern. If we plug in y equals e to the 4x, then we get y squared plus 4y minus 21 equals 0. So let's pretend like this is a quadratic equation in y and solve it. We can try to solve it by factoring. So negative 21 is positive 7 times negative 3. And positive 7 plus negative 3 is equal to positive 4. So that's going to work. Y squared plus 7y minus 3y minus 21 equals 0. Solve or rather factor by grouping. Y is a common factor, so y times y plus 7 minus 3 is a common factor times y plus 7 equals 0. Y plus 7 is a common factor between these two terms, and we factor that out to get a y minus 3 equals 0. So we've solved the quadratic equation in y. However, remember that y is a variable that we introduced into this problem. Let's solve for y first. So this is the zero product rule for solving a quadratic equation by factoring. Y equals negative 7 and y equals negative 3. So we've solved for y, but remember our goal is to solve for x. This original equation is an equation, exponential equation in x. So y is something we introduced. We said y is equal to e to the 4x, and that's equal to negative 7. Now notice right away, when you raise a number to a certain power, a positive number to a certain power, you can never get a negative number. Negative is impossible. So right away, you know that this is not going to give us a valid solution. So let's look at the next one. Y equals negative 3. Y is equal to e to the 4x equals negative 3. I'm sorry, that should have been a positive 3. Please let me make this correction here. That's a y minus, so that should be a positive 3. E to the 4x equals positive 3. Now this seems like something that would give us a solution. We have to solve the exponential equation e to the 4x equals 3. To solve an exponential equation, we use the log function. We take log on both sides. We can decide what the base is. We take it as base e for convenience. The advantage of taking logs is this: the exponent, which has an x in it, now is no longer an exponent. We're left with log e to the base e, and that's equal to log 3 to the base e. Log e to the base e is a 1. So 4x equals log 3 to the base e. We solve for x. So x equals log 3 to the base e divided by 4. You can enter it into your calculator and round it to any decimal place value that you want. Notice that the quadratic equation gave us two solutions: y equals -7 and y equals +3. Y equals -7 didn't give us a solution because e to the 4x, e to the anything can never be a negative number. So that's why we didn't even work on that one. But e to the 4x equals 3 gives us a solution. E to the 4x equals 3 when solved using logs gives us log 3 to the base e over 4. So this is the one solution we get for this particular equation.